For over 20 years, Glasstech Asia has served the Asian glass industry as the main meeting point in the region. Together with Fenestration Asia, Glasstech Asia moves around Southeast Asia and regularly attracts over 200 suppliers showcasing leading technologies together with more than 3,500 buyers from the region.
A very good afternoon to everyone. I'm so happy to see so many of you joining us today. Welcome back to Glasstech Asia and PERAFI webinar series number 4, Team Digitalization and the Future of Façade. Digitalization to me is more than just the use of new technology and data. It is a culture, a mentality shift, and a journey to create new opportunities for collaboration, design, material use, and the creation of new value for growth in our future facade. I am Gwen from Dow High Performance Building. I am delighted to serve as your moderator and host for today's webinar. Firstly, I'd like to applaud Glasstech Asia and PERAFI for creating this platform for glass and facade professionals, including myself, to be able to come together and learn, share ideas, and explore new possibilities. Glasstech Asia, for those who are unfamiliar, is an annual rotating exhibition that focuses on all things glass. Held in conjunction with Fenestration Asia, it showcases window, door, and facade innovations. The good news is Glasstech Asia will return to Singapore next year on 26 to 28 October at the Marina Sands Expo and Convention Center. This is a must-attend event for everyone interested in meeting our industry associates, leading buyers and suppliers, and have purposeful networking. I'm not sure about you, but for me, I definitely is missing such events because of COVID. So again, 26 to 28 October 2022, I hope to see you there. I would also want to acknowledge PERAFI, Indonesia Facade Association, an independent organization dedicated to improving the quality of building facade industry and developing long-term and meaningful business relationship. So a call out to all our Indonesia fellow colleagues. So please do check out and join as a member of PERAFI if you have not already done so. So before we begin, just a few housekeeping. Please be aware we will disable your video and your microphones. Throughout the session, if anyone has a question for our speakers, you can post it directly to the Q&A chat. If time permits, we will address the questions after each speaker's session or towards the end during the panel discussion. You may also visit glasstechasia.com website after this webinar. As I'm told, the most asked question will be answered in the professional conversation page. So our program today will be around 2 hours, and we have 4 veteran speakers with very diverse and rich expertise, bringing us provoking contents on digital workflows, advanced materials technology, and digitalization journey. So before we begin, we would like to thank our sponsors, Kurare, the leading manufacturer of PVB and advanced interlayers for laminated glass under the master brand name Tosifo. Pilkington, Russia, a world top manufacturer of high-performance soft-coated glass co-owned by NSG Group. So without further ado, let's dive into our program today. So I would like to introduce our very first speaker, Daniel Chandra, Director of Digital Technology at Ong & Ong Group. Daniel has a track record of providing significant value to stakeholders through his leadership in digital transformation, which include the use of BIM, VDC, and IDD technologies. So we are very thrilled to have him share with us today on the topic, embracing the digital workflow. So Daniel, whenever you're ready, take it away.
All right, thanks, Gwen. Thanks. Afternoon, everyone. Yeah, my name is Daniel. I'm from Ong & Ong Group. Okay, let me share my slides. Just 1 second. Okay, everyone can see my screen, right? Yep. Oh, good. Okay. All right. Okay. So yes, my name is Daniel from Ong & Ong Group. So today I'm going to share about Ong & Ong digital transformation journey. I'm calling it digital workflow. Right. So that's my title, embracing the digital workflow. Right. Okay. Okay. So just for the benefit of you that probably not familiar with Ong & Ong. Okay. So just quick introductions about the firm. Ong & Ong Group, we're present in 7 countries, Singapore, Indonesia, Malaysia, Mongolia, Myanmar, Thailand, and Vietnam. Okay, so we have design entities, which are Ong & Ong, SCA Design, Immortals, and OXT. And we also have engineering, CNS, and M&E under the entity called Rankin and Hill. And we also have project management, which is project innovations and project actions. Right, so we have about 570 staff strengths across the region. We're offering pretty much multidisciplinary design consultancy. So we are architects, interior designers, landscape architects, branding consultant, structure consultant, structure engineers, M&E engineers, and project managers. Okay. Right, so before I dive into the digital workflows and all that, and then how Ong & Ong's journey in terms of the digitalizations comes along, and of course, the fact that in Singapore, we actually have to embrace IDD, what we call is integrated digital delivery, right? And how this IDD is actually connected to the facade or building design in relation to the facade, treatments and, perhaps doing some massing, conceptual design, and then some building skin treatments and so on. I would like to touch base a little bit from the base of the approach, which what we call is building information modeling. I hope most of you are familiar with the building information modeling before. So in Singapore context, for example, we started back in 2010 when we started this with BIM, right? So Singapore government basically pushing the consultants in particular to actually embrace BIM in their design and also in their for authority submissions and building approvals and so on. So BIM essentially is basically we model the thing first virtually, and we produce the drawings that comes from the model. So it's not the other way around where actually you create plan, floor sections, elevations, and then get the models after that. But you actually started with the model first, and then drawings comes later. All right. So the use case of BIM is pretty much across the board from start to finish of the project, starting from design development, conceptual design, including authority submission for Singapore context, right? 3D coordinations and so on, and all the way until FM and some automations and so on. Right. This is what we have for the BIM. Now, Singapore also embraced what we call is a virtual design and constructions, which is VDC. So that was back in 2015, which pretty much basically another so-called enhanced process of after the BIM. So we have BIM, we have ICE, which is the integrated concurrent engineering, where everybody is actually get it together to do some coordination using the model, using the BIM model, right? And then some processes of productions and management, things such as DFMA, for example, or design for manufacturing and assembly. So all of these actually part and parcels to create a virtual mock-up of the actual thing before it's actually built. So what we call is like, we build it twice. So conceptually, we build it in the computer first, then after that, you build it on site, right? Just to give you an idea, is like, this is one of our projects using the FDC process that we built the whole entire thing virtually from design all the way to the construction process as well, meaning to say, like, for example, like site logistics, like how these things actually being constructed and so on, from the building structure, architecture, M&E, as well as the facade as well. So step one is, of course, is build the thing virtually using BIM technology. And then second of all is actually to build the thing on site, right? So make sure everything is actually no issues, no clashes, no problems. Then you actually construct it on site, right? So that's the holistic approach of VDC, which is pretty much having the approach of digital twin, where you actually have the physical and the virtual together, right? Now, IDD, this is one of the latest approach of digitalizations from the BCA Singapore. The earlier approach was started back in 2017. So IDD definition is integrated digital delivery. There are 4 pillars in there. First one, which digital design. Second is digital fabrication, digital constructions, and also digital asset delivery and management, which is pretty much the FM, or what we call is facility management, right? So for the purpose of today's discussion, I mean, IDD is quite a lot of things to discuss if you go through everything. So for the sake of today's discussion, especially the one that relate to the facade models and processes and workflows, to create the facade design, it's pretty much a digital design, which is on the left-hand side here. It's about how do we optimize the design for the facade, how to actually to do some perhaps it's simulations and analysis on the building itself, right? And how to actually to integrate the whole process together with BIM and VDC, right? I'm going to touch base also about the cloud, because especially the nowadays with the needs of collaboration, how we actually move from traditional method to the digital method. Cloud-based is very essential, especially with the implementations of common data environment. Okay, so I'm going to share you a bit of that as well as part of the base infrastructure to set up the whole entire workflow. Right. So in on context, digital transformation pillar, we come up with strategy, what we call is a digital beyond. So it's basically a three prongs approach. First is the workplace, digital workplace. Second is digital workforce, sorry. And then last would be the digital workflow, right? So we kind of set up our digital workplace as a base to enable the other two, right? And also, of course, our staff and manpower need to be trained and need to be so-called, move their kind of, I guess, or change their mindset, right, to embrace the holistics of digital transformations. And of course, after that, the workflow itself actually need to be, basically embracing the whole tree approach again, and then and deliver it in a digital way rather than doing the manual way. Right. Okay, so I'm going to start with the digital workplace, which are the difference between the standalone and collaborative, right? So we're moving away from standalone to collaboratives, in the sense that, okay, I think when we started BIM in 2010, 2011 and 12, back then, it's kind of a standalone in a way, like, okay, we're doing our own architecture models, we, consultant doing their own structure models as well, our many design partners also doing it on their own. But we got to move into something more collaborative now with the whole effort of IDDs and VDCs and so on, right? So collaborative is the next way, is the way to go. So we need some better infrastructure rather than a standalone setup. So virtual workplace is actually one of the key thing here. So we embrace virtual workplace. Is basically a collaborative working environment. Of course, we have the touch base across the three things again about the hardware, the peoples, and the online processes, right? So basically, a virtual workplace is a workplace that is not located in any of physical space. So we're utilizing what we call is a cloud base, right? So instead of okay, this is an example of work from office kind of with the physical setup and an on-premises kind of environment, and then moving to work from anywhere, where the infrastructure is actually virtual and then using the cloud base. And this is what we embrace as in our practice. Okay, the whole workflow transformation from standalone to become collaborative. Some of the examples of the implementations actually including this cloud-based design or BIM meeting reviews, using the facilities such as AR, VR, and MR, right? We have our own in-house training center to ensure our workforce is actually digital ready, and utilizing things like virtual desktop, for the cloud-based BIM workstation. So is a with the BIM software, you need a powerful hardware, right? So the way that we actually implementing is actually we utilizing cloud-based also to do that. So everyone actually have this access pretty much from anywhere. We have some platform sharing called Beyond X to share our kind of digital journeys and digital sharing sessions, which happen every year. Of course, the training centers again, and then we set up the whole thing with the focus on mobility, so to make sure that our staff can work anytime and anywhere. Okay. Now, going back to the IDD, the IDD is basically is about digital delivery. Digital delivery, when you talk about digital here, is about the data, right? So why digital workplace is important for IDD is because how we need to make sure that the data is actually entered correctly and then collaboratively correctly being implemented in the system, right? And then so therefore the project can be delivered without any issues and any dramas, pretty much, right? Right, so we embrace what we call as a CDE, Common Data Environment Platform, right, to support the IDD framework. Again, is that is to ensure that everyone's actually working from the same data source. Okay, it's not like, okay, one consultant having their own thing and then their own data set, their own floor plans. No, we don't do that. Basically, everyone needs to work in the same digital environment, in the same cloud-based environment, which is the common data environment that we are looking to. Okay, right. So in on context, this is in the setup that we currently using now. So we move away from the server environment because we have 7 offices around the regions. So we move everything to the cloud now. So this is what we have now. It's a common data environment across the offices. And also we sharing this with our consultant partners and main con as well as subcon as well. Right. So this is an example of projects that we did using the common data environment and successfully won an award as well. This is one of the healthcare projects, and another one is private residential projects, which is one of the first IDD, one of the first 12 IDD projects in Singapore. Right. So that's one of the example. Now, speaking on the workflow, of course, the reasons CD is actually important is because it's the platform itself, right? So in terms of creating the BIM model and then conducting VDCs and then integrating it into IDD workflow, that become one of the enablers, right? So therefore, an example like for this, we can enable a multidisciplinary BIM model. So every disciplines, every consultant actually work in the same file, same model. Essentially, it's actually one single file, right? So with the real-time authoring as well, we need this kind of infrastructure to be enabled first. Right, digital design with computational BIM, this is something that I'm going to talk more after this, which is related to the facade treatments of the building and how actually to generate some facade options from this tool. Right. This is one of our add-on tools that we develop in-house for BIMomatic, another way to automate the process to ensure that the IDD process of automation is actually being implemented much better or more efficiently. The FMA, of course, is the next levels of digital fabrications in IDD. So it's quite one of the key things that we actually deploying in office. As well as for the FM handover. So when the project's finished, for example, then we scan the buildings using LiDAR scanner. Then after that, hand over the model together with all the sets of the FM data. Right. Okay. So how much time I have? Okay. So the generative design, digital design use cases for IDD. I'm going to touch base on this. So pretty much about the parametric modeling, computational BIM, and generative design, right? So just imagine we have this kind of a square cube, right? Parametric modeling and computational BIM and generative design is one of the methods that we normally use to do the facade treatment for the building, right? Which is part of the IDD use case of this, the one is listed in the BCA's IDD. So okay, just imagine is a box like this, right? What it does is basically, if you can see here, is we manipulate the box, right, with different heights, with different lengths, with different perhaps is configurations of the width and the height and so on, right? And then arrange them accordingly with certain patterns, right? So this is how we actually manipulate the models and do some options for the facade, for the building skin, for example, right? And then once we manipulate it with a script like this, then the computers also can offer us a series of options. So these are the examples of options that being offered. So there are so many pages of options that actually being displayed by the computer. And then as a designers or architects, actually, this tool is quite helpful. Right. So essentially, these are the idea how the parametric modelings and generative designs and computational BIMs actually work. Now I'm going to show you some of the case studies from the project itself. So this is one of the example of projects of master planning with the 2 towers. I think it's residential, right? So it's a typical so-called building massing thing. So we have a typical towers like this, right? With the set up with the ventilation gap and also some balconies and terraces and so on, right? And then this is one of the samples of the floor plans, right? So the floor plan layout 1 and layout 2, there's 2 different things with the balconies, fenestrations and stuff. Now, after that, we're playing around with the vertical clusters. Right? So how these vertical clusters actually works, actually, we can actually set the different permutations of the massing itself using the script, right? So this is an examples of how it works. So we're using dynamos on this. Models is done in BIM using Revit software. So we have these kind of sliders to change the modules of the facade, right? And then a few sliders there to randomize the pattern. So it creates a different treatments of the facade itself, right? But that's how it works in terms of getting the different kind of feels of the elevations of the buildings using the script. Another example is this one is using generative design, which actually the computers giving you different sets of design options, right? And you can actually choose which one that is actually suitable for your case. And there's another set of scripts using Dynamo. set the side dimensions, plot ratios, and so on, and then some facade divisions and rotations angle and stuff. This is an example, for example, with the paneling options that, with twist the massing, use a different size of paneling system, and then this one is a square one, and then the other one is like a diamond shape, right? And this is some of the output of the outcome of the design, with the model twistings and foldings and flowers and staggering, right? So with two different sets of scripts. Another option is also this one. This is another exercise of permutations of materials, so different sets of building materials and color, right? And also the panel between solid panels and void panel, and another one with the checker options as well. Okay, so again, we're using script to do this. So basically, it's input to get the materials, to get the sizings and so on, and then we process it and after create the output into the model. This is another, this one is for analysis. So basically the facade treatment, how actually the panels actually correspond to the sun, for example, the sun angles and so on, right? So to give you a bit more details on the idea is, okay, how these vertical panelings actually respond to the sun orientations. Okay. Now, another example is dynamic architecture panels. So how these things actually create more kind of a dynamic shapes, different sets of opening, right? So it starts with the a simple rectangulars with the openings in the middle, right? And then after that is we join them together in the using parametric design to actually to array them together, right? And then with the sliders, you can actually adjust the openings and the closings of the actual panel. Okay. So maybe next. Okay, so now with this, we can also create a different sets of I guess more dynamic kind of gradients kind of opening rather than just a flat one. So all of these actually done by the scriptings and actually the visual programming like Dynamo, for example, really helpful for us to actually to generate all of this, right? And then we can actually adjust the sign diagrams, the sign graph here to actually to correspond with the openings as well. Okay. So, and yes, and this is the final outcomes of the facade itself to have that kind of a dynamic openings and closing. Right. So I've shown you all those examples. So basically, in our context, we actually author all of these in using a cloud-based environment. So authoring from design, modeling, analysis, and simulation all done in the cloud, as well as doing the coordinations as well with other consultants, right? So we use 100% cloud-based in there. So what is the difference now? This is the traditional way of non-CDE workflow, right? So we model the facade. Normally we have to export because you may use different software, right? You may use different applications to export to another format, and then you get uploaded somewhere because you need to send it to another consultant. Say, for example, facade consultant want to send it to architects consultant, right? You need to send it up, upload it, and then the model, perhaps you use like a third-party cloud solution or third-party FTP server. You have to actually temporarily store it somewhere, right? And then the other party, the architects, actually download them. And then after I have to import the models and then do coordinations and integrate. Now imagine if this one needs to be repeated over and over because design keep changing, like for example, every 2 days or every week, for example, right? So the process is quite tedious. So in our context, we set up what we call as a CD workflow. So everybody's actually work in a CD environment. So we model, export, coordinate, and integrate in the cloud-based CD. Everything's in one place. So facade is actually one of them, okay? So in the sense of this is facade consultant is just doing it here as well. Architects doing it here, and then as well as M&E and structure. So all the models actually sits in the same common data environment, which is in the cloud. What's the difference? The difference is between sending and upload, we have with non-CD workflow is we have disconnection. We hand over the model rather than doing it by sharing it. So we're working in silo. I think that's the most kind of challenging thing. With cloud-based, actually, we maintain everything in single source. We invite them to collaborate, right? So we don't hand over the model. We actually get the team to actually join the cloud space, join the virtual space, right? And then, of course, all stakeholders, all the project team normally have to start from the start. So everybody is actually get the correct setup from the beginning, all right? So what we do is basically we just share the files and then share it to that person, and then they can actually just jump in and do it, the models in there. All right, so digital workflow, basically we're going to see more of this happening, I think, in the next few years or even now. There are many companies also already embracing this. Virtual setups, I think, is the way to go. I mean, we always use this Zoom or use MS Teams, for example, to do some conferencing and so on, right? So integrated model is the key. We no longer, I think individual models become an issue now. If you only have your own model, it's not integrated in one space, actually can cause issues in coordinations, right? So there are more people actually embracing platform-based now for the CDE, so to set up their infrastructures. And also use the automation tools. So automation can be like, using, simple script with Dynamo, like, for feature programming, or maybe some other tools that you may have, right? So integrated model, of course, your BIM is now become more, it become like multidisciplinary BIM rather than a single standalone BIM. It helps on the VDC if you have a platform, of course, and of course with the automation tool, like visual programmings and all these things help on your automations for the ideal delivery. Right, so for Ong and Ong, just a quick one to recap, we embrace workplace, workforce, and workflow as one holistic digital-centric initiatives, and basically to prepare us to become a future-ready practice, right? So we embrace the whole cloud and then working anywhere with the mobilities and so on. Just to give you some summaries on in the video form. If you don't mind, I'll play you this one, a quick one. Just a few more slides to write up. Okay, so this latest award that we received from BCA is for IDD, so we got platinum 2 months ago. And we also so-called accredited for the ISO 19650. This one is a international BIM standard, which is the one of the we are one of the pioneers in Asia to get these certifications, and one of the latest digital maturity roadmap of from the IMDA scoring, and then some media coverage in Business Times, as well as the Autodesk customer success stories for the again, it's for the cloud implementations and ISO 19650. Okay, so that will be all. Okay, so thank you so much. So open for Q&A, I guess.
Hi, Daniel. Thank you so much for the insightful sharing. Digital workflow is definitely bringing a lot of value to our future facade. In the interest of time, we will do the Q&A towards the end. So now let's move to our next highlight, where we will examine the possibilities of estimating visual distortion on facade during design stage. I'm pleased to introduce Selva, who will answer this question and provide more during his presentation. Salval is from Pilkington, Russia, and he heads the project's technical department. So without further delays, I'll hand over the time to Salval.
Thanks a lot, Gwen. Good afternoon, ladies and gentlemen. Warmest greetings from cold Russia now. I see it's quite an audience. So let me start the screen. Before I begin, let me pass my regards and many thanks to my friends from PERAFI and Glasstech Asia for giving me an ability to address to you. Very few words about us. The Pilkington company is established in 1826, so in England. Now we have a factory in Russia, near Moscow, from 2006, which produces glass and high-performance coated glass, which its brand name is Suncool. And this glass has wide variety of parameters set for any building. And the thing is that our factory is very export-oriented. So we export to around 40 countries around the world and have an architectural projects there, from Mexico and Honduras to New Zealand, and of course to Southeast Asia also. My name is Slava. I am head of a technical department for export projects for our Russian factory. And let's go into the topic. Today's topic is a visualization, but in my opinion, visualization is good when it brings you very close to the reality on the facades. And I will be talking about visual distortions, meaning distortions on the facade. Because when you're pretty much everyone, including architects, they are doing modeling of the facades. On the model, they all looks nice, good, and perfectly flat. The glass is perfectly flat. But when it comes to reality, and the building is ready-made and done, there are a lot of distortions which you can see in many cases. Of course, most of them because of physics. Physics cannot be avoided, you know, we're living in the physical world. And today we will be talking about how to estimate the correct IG unit composition to minimize these distortions. First of all, usually for any big building, the calculation of IG unit is made in terms of its performance, of course, and because in terms of its behavior on the facade. The static calculation usually gives you two results. First one is maximum stress on the glass, which means if the glass will be broken under the loads or not. So under the wind, under the temperature, this thing. And the second thing is glass bending. So those two parameters you get from usual calculations. But the very important thing is how to correctly see and interpret the results of the calculation. Usually, we take into account several load factors. Wind load, of course, because if you're building a tall building, the wind will be very high. Second one, and very important, are the climate loads, because IG unit inside has some air or argon, meaning gas, and it is hermetically sealed on the perimeter. So when the IG unit is installed, when it gets heated up, the gas expands and the glass bends, creating distortions on the facade, which many don't like really. Of course, apart from these two most important ones, wind and climate, we take into account snow and other special loads. Fortunately, snow load is case for Russia, but not the Southeast Asia, except for mountains here. So some examples of our weather is included on the slide. Okay, jokes aside. Usually, glass is calculated under extreme load conditions, meaning the wind, which can happen once per 50 years, so twice a century. This is very important because the most important function of the facade is to withstand maximum load combination and do not break. Nobody likes when the facade pieces are falling apart on the people's head. But if we want to bring it closer to reality, meaning visual, what we see every day, nobody will look on the facade when it's a hurricane raging. And the thing is that if we look to the bending of an outer glass, because the outermost glass gives us the impression of the facade. And when we take maximum loads and usual loads, the results are extremely different. You can see it on the slide. Let me set up the, yeah. So here, this is glass deflection, and the external glass is deflecting in one way under peak loads and in completely different way under the climate loads. So for comparison, there are two IG units combinations which are calculated rather differently in this case. And the goal today is to estimate how the glass will look like in real life, not under peak loads. So to sum up the first part, regular calculations are done under maximum loads, under worst happening conditions, and they give you completely different results. To get back one slide, the most important thing in every calculation is glass, in every peak load calculation is glass stress, meaning we are estimating glass breakage. And the glass breakage and the conditions under which the glass breakage happening are not valid for our estimation. So how do we minimize these optical distortions and how do we predict them? We need to determine the correct load condition. So, and here is a good example of the facade with the lens effect. If you see on the top of the picture, that is how the visualization of the facade with the via digital instruments looks like. So this part. Oh, sorry. Yeah, this part. It doesn't reflect anything, and the glass is absolutely flat. But what we're trying to estimate in advance is this part. So how many distortions you will get. In order to get the correct result, you need to take consider the lens effect first and foremost. And in order to understand what do we do, let's see which kind of loads can be applied. Peak loads, so maximum wind, usually has very short duration. Special laws like human impact also have very short duration. So in normal life, we don't expect very big wind bursts. And here comes climatic part and snow part. But snow part, again, for those countries that are very snowy. Out of that, we can gather that climatic loads are the most important thing for us. And under these loads, the visual performance of the facade should be estimated. So these loads are long time, and we are good with that. So climatic loads here should be throw away the wind. In fact, no, because the wind is, not the strong wind, is regularly present, but we should take the wind which is happening every day, under everyday conditions. And there, we can go to the calculation process. The climate load are most important, as we understand before. So, but what is the climate in terms of IG unit? For IG unit, the temperature which is inside the IG unit does matter. The temperature of the gas between the glass. By the way, if you install single laminated glazing without gas, this thing is absolutely mostly unaffected by climatic loads, which is good for lamination, but very bad for energy efficiency of the building in terms of solar control and U value. In order to understand what is, how to calculate the temperature inside the IG unit, we need to calculate its parameters, take into account climate outside, including temperature inside building and temperature of the outside air. We need to take in account solar radiation, sky temperature, and average wind speed, meaning if the glass is overheated, the wind is good for you because it takes away the heat faster. Combining all of these, we can calculate the temperature of the gas inside the IG unit. Of course, the more solar absorption it has, the bigger the temperature will be, and the bigger the deflection will be. Also, it goes for the spacer. The wider the spacer, the more gas is inside of it. And the more gas, the more the gas expansion. So we estimated the temperature. Now it's time for us to estimate the rest. First one is the pressure, meaning atmospheric pressure. This is mostly happening for the buildings, high-rise buildings, skyscrapers. But it's also very important to take into account if your building is located quite far away, and most importantly on the different sea level than your building. So building and production. Difference does matter. In some cases, if you are producing your IG units on the sea level and then transporting them high up into the mountains, you can install special valves to dump the pressure out. But these are nuances, but they can also be taken, considered in the calculation. So temperature, pressure, and height difference, plus the wind. For wind, we can use normal climatic data from our internet, from the websites with dealing with weather, to see average wind conditions. Usually, the conditions are present like at a wind speed, but wind speed can quickly be transformed to pressure using the simple equation. And mind you, we're not taking peak wind speed, maximum. We are taking regular wind speed, which is happening every day. Our goal, again, to calculate everyday situation. Combine all of this and go to the results. So I will sum up really all of the points which I've done. So deflection of an outside glass is the key. All of the glass are deflecting, but for us, it's very important. A glass, outside glass is very important. Furthermore, if you're using high performance glass with coating, it's usually a little bit more reflective than the normal one, giving you another reason to look specifically for outer glass. Now, the really important, so we combined all of the things together and get the results. Glass deflection. How to evaluate it? Because IG units, the size of an IG units can vary wildly. You can have 1 meter per 1 meter, and you can have 3 meter per 6 meter, for example. The deflections will be different. So the key here is to evaluate the millimeter of bending per 1 meter of shortest side of glass of an IG unit. And in this, you can compare big IG unit to a small one. From our experience, 2 millimeters per meter of bending under normal conditions is usually considered acceptable. And of course, the main thing which is affecting is the thickness of the outer glass. That is the thing which usually not considered on American market, surprisingly for me, because those guys like thinner glass and it can bend like a sail. But outside, from an outside, it will not be looking good. Of course, the reality gives us much more to think about. There are several other factors. First one is the most important one is the glass reflection. The more reflective is the glass, the more visible this optical distortion, the glass bending will be. So the more reflective the glass, the bigger the requirements for a proper IG unit design in advance. I understand, and the same goes for darker glass, because if the glass is dark, it lets much less light inside of the building. So the lighting difference outside of the building and inside is much bigger. And that gives us visual reflection. Even if the reflection number is the same, the visual reflection is bigger. So the darker glass, the more reflective it is, the more you need, the more attention you need to pay to the proper IG unit design. And these requirements of 2 millimeters per meter can be lowered. And it all can be estimated in advance. Please bear in mind that I'm not saying that the calculations which are done now are wrong. No. The calculation under maximum loads are absolutely necessary for you to give your building safety. But in addition to this, you can estimate the visual look on the facade by conducting a special additional calculation of the climate under climate loads, under everyday loads, and see and compare different combinations of IG units depending on what you're planning to do in a building. For example, this is, sorry for a lot of numbers, but I will highlight you the key numbers. IG units are calculated under peak loads on the top here, and you see the bending. These are huge. Does that mean that, does these numbers mean anything to us? No. Under peak load combination, we should be looking not for glass bending, but we should be looking for the stress on the glass. Will the glass hold? If it does, we have no problem. Let us continue, go on and make a calculation of the climate loads. And you see the numbers are vastly different. And here we can compare IG unit compositions in terms of bending. And in here, all of the, mind you, all of the size is the same. And here we see that if we install thicker glass as an outer pane, then the bending will be much lower, and your facade will be much more straight, uniform, and good looking, basically, because that is the goal of this visual estimation. Now, we are in Russia, we are performing these calculations for a long time already. And usually we provide customer with both of them. For example, so for him to see, will the IG unit hold, first thing, and how to compare different IG unit combinations. This is the key for understanding the behavior of the facade. Of course, it can be also visualized, and the previous speaker has a very good presentation about beam possibilities. It can be all be visualized with beam and visually estimated in advance. Some nuances to this, because different IG units react differently on the loads. Here, you see that the facade is made of exactly the same IG units of exactly the same size. But here we have transparent zone, and in between we have non-transparent zone. Again, combination and size of the unit, IG unit are the same, but visually the non-transparent part is looking much worse. That is simple because usually it has IG unit, the IG unit for a non-transparent part has standard glass outside and painted glass in the inside. That means in the summer it will heat up a lot, and on the winter it will be much colder. Oh, okay, if you have a climate difference, because I once looked for a climate of Singapore and the temperature was for the whole year was like this, straight. A little bit of envy from my side, but okay. So back to the point. Different facade parts should be evaluated separately if you want, and the IG units for a different building part should be designed separately. So the composition could be different for a non-transparent part of the building, even if the size is the same. So basically, this is it from my side. The point of today's topic was that please be smart in your approach to the building, because visually on the architect's render, it always looks beautiful. But when you come to the details and you will come to the realization of your building, there could be some problems. And it is far better to use the expertise and to estimate the bending and the distortions well in advance to get the correct IG unit composition for you. A little advertisement. We are Pilkington, Russia. We can do that. 20 years of experience, I might say that, not only in Russian climate, but all the others. And you can address us in this case. Thanks a lot for listening. I hope that it was helpful to you and you will learn something new. Thanks again to PERAFI and Glasstech Asia for providing me the possibility. And
thank you, Salva. It is definitely helpful what you have shared. Very interesting. And I like to encourage the audience. Yeah, I like to encourage the audience to keep pouring in your questions. We may not have the time to answer, but then we'll do it at the panel discussion session later on. So in the interest of time, Salva, could you just answer one question that came forth?
Yes.
The question is that, so is it really necessary for climate like Southeast Asia to use a DG glass for facade?
It depends. Thanks for the question. Right, it depends, but mostly I would say yes. Okay, everybody knows what is happening with the gas prices and oil prices right now, and electricity. And the heating and, for Southeast Asia, cooling of the building is consumes a lot of energy. Of course, if you're building a residential building, so the people attending for themselves, but if the building is commercial and have central cooling system, centralized, then IG units can provide you incredible savings in terms of not only of the price of cooling itself, but also the installation power of the cooling system could be much reduced. So as the price of the cooling system. So if anybody is building a building for themselves, yes, he is investing something into IG units instead of simple lami or tempered glass. But he can gain it from the equipment, the drop of the equipment price, and for sure he will gain it from the reduction of the costs. Okay, that's not the point of my today's presentation, but it also can be digitally estimated. How much can he save? What is the buyback period?
Returns.
Yes, thank you, Gwen. What is the returns period of this? It all can be estimated in advance, and you are free to address and compare.
Great,
but
great.
The answer to the question, in my opinion, yes. Not because because we are the producers of the coated glass, but because of the reasons which I explained.
Yes, I totally agree with you. Having a high performance double glazed unit will help us to achieve a better energy efficient building. So now from
one quick remark. For Southeast Asia, it is the question of lami and double glaze. For most of the Russian climate is the question of is it the double glaze or triple glaze. So we have our own problems.
Right. Okay, thank you so much. I think from
Thanks,
the world
Ben.
of glass, from the world of glass, let's now move to the world of interlayers. Security glazing such as bullet and blast resistant glazing is typically made up of many layers of glass and PVB. So the assumption is that such glazing are usually very thick and heavy. So we are very pleased to have Malvinder, Senior Technical Program Manager of Curare Pacific, to enlighten us today on the topic, are thinner and lightweight security glazing possible? So Malvinder, over to you. Malvinder, you're on mute. I think you're still on mute, Malvinder. We can't hear you.
Yeah, I'm sorry. Yeah.
No worries. So
okay.
Go ahead.
Yeah, I hope I'm audible now.
Yes, we can hear you well.
Okay, great. Thank you very much for the introduction, Gwen. So I can see we have people from different corners of the world. So I would like to say a very good afternoon, good evening, good morning, if we have some people from Europe. Okay. So my name is Malvinder, and I'm working for Curare as a Senior Technical Program Manager for the PVB division of Curare, and I'm based out of New Delhi. And the topic for today's discussion is, are thinner and lightweight security glazings possible? So for a moment, you might be thinking that, how this topic is related to the theme of today's webinar. Yeah, I would say it's definitely linked to that, because when we talk about the future of facades, like how the future facades will look like, then I think it's very important to touch on the topic of security, because in the past few decades, security has become a big concern, and especially the infrastructure buildings that have become the soft target of so many incidents of terrorism. And that's why it's very important to talk about security. And we will see that how Curare's advanced interlayers are actually helping make the facades lighter and thinner. Yeah. Okay, so before we dive deep into the subject, it's important to let the people know who we are and what we do. So we are the leading manufacturers of different interlayers for different applications of laminated glass. And I'm not going to name each and every application. You can just read it. But yeah, the focus for today is definitely security. But we have solutions for all the applications of laminated glass that you can see on the screen. Yeah, so we will see that how the solutions for security that are with Curare, they are helping improve the or add more value to the facades.
Alvinda, sorry, will you be sharing slides?
Oh, is it not visible yet?
Not yet. You probably will have to click share screen.
I'm so sorry. I'm so sorry.
No, no worries.
I thought I shared it already. Is it visible?
It's coming. Yes, it is right now.
Oh, I'm so sorry. Yeah.
No, no worries.
Okay. Yeah. Okay. Okay. So I was giving the introduction of like who we are and what we do. So we are the leading manufacturers of the different interlayers for laminated glass applications. The different applications have been highlighted on your screen, starting from safety, decorative, acoustic, structural and security, and specialized applications of laminated glass. But for today, the focus is on security applications. And we will see that how the advanced interlayers from Curare, they are helping the facades become leaner and thinner. Yeah, so I mentioned in the beginning that security has become a new trend for the facades, as we have seen, as we can see at the global map. Very few countries have been actually spared from the incidents of terrorism in the recent 2 decades. Countries as far as New Zealand, they have also been affected by the incidents of terrorism, and even the Singapore government has also been talking about making their airports facades which are resilient against blast attacks. And on the right hand side, you can see the picture of Brussels airport, which was attacked in 2016, and the below is a aftermath of what happened. You can see the people, they may not have been injured because of the direct impact from the blast, but actually the glass shards, those caused some grievous injuries to the people in the vicinity of the airport. So in those type of situations, glass actually becomes a secondary weapon, which can be very, very critical for the design of the facades. And also, we have seen not only the rising incidents of terrorism, but also the civil unrest has been growing in many parts of the world. It could be political unrest, social unrest, or the reason could be anything, but we have seen that often the corporate buildings, the big fashion brands, they become the soft target of the mobs, and this is mainly because layman thinks that glass is a very weak element of the building, which can be broken very easily, and people can loot or cause destruction to the building, or cause loss to the property by just damaging the glass and entering into the building forcefully. And then this poses a great amount of challenge for the designers to come up with a facade that that can actually sustain those attacks. And then there is another trend that architects, they love to have big glass panels with minimal frames, and this is putting an additional challenge for the designers to design glasses which are capable of sustaining those kind of attacks. So when we talk about security glazings, then it's important to remember that the intent is to protect damage to the property from man-made attacks, or it could be natural hazards as well, like in case of hurricanes, or like there could be floods. Then the primary attack from the threats is actually borne by the facade of the building. So with a proper design combination, you can make the facades resilient for those kind of attacks. So before we go into the deep subject of security glazing, it's important to understand the behavior of the glass and the different breakage patterns. Why it's important? Because sometimes people end up making the mistake of using the wrong type of glass for security applications. So the breakage pattern is very important, and the annealed glass is on the left hand side, which breaks into big shards when broken, and it can cause grievous injuries. It's not even a safety glass. And then we have the tempered glass, which breaks into small fragments. It's a safety glass as recommended by many of the country standards, but it would be wrong to say that it's a security glass. Many people they say that I have put up the strongest glass in my house or in a building, and but it's not making you secure. And then we have the laminated glass, which is the best safety glass that you can have. But I would say it's the entry level of a security glass, because the safety level or the security level that will be provided by the laminated glass is actually determined by what is in between the two layers of the glass. So which means the thickness of the interlayer is going to govern the level of security that you will get from the glass. So here more clear comparison of what are safety glazing and security glazings. It's important to remember then when you are when the intent is just to protect the people from injuries from the glass, you need safety glass. But when you are trying to get more from the glass and you want to prevent the people from breaking in, forcefully entering into the building, then you definitely need a security glass. And here the intent is to increase the break-in efforts or the time that is needed by a person who is forcefully entering into the building. And the security glazings, they should not be confused as a standalone solution, because here we are trying to gain more time so that secondary alarm systems, they get activated, and eventually security glazings are made of man-made materials, and every man-made material can be destroyed. So that's why we make it very clear that this should not be confused to be a standalone solution. And then next important point that I need to highlight is never ever consider tempered glass for security applications, because the breakage pattern, as we have seen in the previous slide, that is very poor for a security glazings, and you will have a wet blanket effect if you use that. Yeah. And lastly, the design of a security glass is influenced by the anticipated threat level. So you or your client must have a very clear idea about the anticipated threat levels. So what is threat level, we will talk about in the coming slides, and whether SPAL is acceptable or not. SPAL is like the risk of injuries to the people who are sitting next to the glazings. So this is relevant for the BRG applications or the bullet resistant applications. So we will touch that topic also in very detail in the coming slides. Yeah. Then moving on to the security hazards from the man-made threats. Here we have some pictorial illustrations of what are the man-made threats. Like first we have forced entry. When somebody, a thief or robber, is trying to enter into the property, trying to steal something from the building. So you need to have a burglar resistant glazing over there. Then the higher level attack is a firearm attack, when the attacker is like carrying some firearms. The example could be again private buildings or some government buildings or some banks. And then we have a higher level of threat, which is a bomb blast or an explosion happening outside the building. So last year we saw what happened in Lebanon, when some explosives were stored around these buildings, and these caused catastrophic damage to the facades of the buildings. So so when we have to mitigate the threat from these kind of attacks, you need security glazings, and these have to be designed properly with the right anticipated threat levels. So when we talk about anticipated threat levels, then it's important to standardize the things. And the most commonly used standard for checking the performance of glazings for intrusion is EN 356 standard. Very common in Europe, and something similar to that is now happening in India also, in my country. And then we have the one standard in US, which is ASTM 1233. So this standard has different types of impacts. As you can see in the picture, the first we have the ball drop test is there. This is for very low level of security glazings. In this case, this 4 kg steel ball is dropped a number of times, and it is observed if it is capable of causing a penetration into the glass. And for high level of security glazings, the test is done by using this mechanized X, and the intent is to make a cutout in the glass, and the number of blows which are required to make out a cutout, these are recorded, and accordingly the glazing is given a rating. Then it's important to mention that, you know, when we are designing security glazings, not only the glass, but the framing is also very important, because otherwise, if you have got a very good security glazings, but if the frame is not properly designed, and the good security glass can actually come out of the framing, and the entire purpose gets defeated, you know. So it's important to test the window and the frame together, and the standards that you see mentioned on the right side of the screen, these can be used for testing the glass and the framing together. But for today, we are focusing on glass. So let's talk more about the standards on the glass and how this test is done. The ASTM standard 1233 standard is a standard which requires the impact on the glazing to be made with different kinds of tools, starting with blunt impacts like a sledgehammer or a pipe. Then it can have sharp tools like chisel hammer, angle iron sledge. As the threat level goes higher, you may have a requirement of thermal stress and chemical deterioration as well. Because when a mob is trying to attack the glazing, people can be very innovative, and they can attack the glazing with different means. And I have a video which I will just play in a few seconds. Yeah, but the intent is to stop the or increase the time and effort as much as possible. And the pass criteria that has been mentioned in the standard is if it is the glazing is capable of allowing a diameter rod of 3.3 meters, 3 millimeters rod can actually pass through the glazing, then it is considered as a failure. These are two criteria. And then we have a block of 200 by 200 mm. If this block is able to pass through the glazing, then it's considered as a failure. And then let me just show you this video. So this video illustrates that what happens in real time, that like people are attacking this glazing. This video is from New York. What happened last year after some incidents of civil unrest in parts of US, in New York and other cities. So this was a big fashion brand where people are trying to enter forcefully into the showroom because they want to loot. Yeah, so here we can see like a variety of tools have been used, starting with a hammer, and they are kicking the glass. So luckily it was designed with sentry glass, and that's why it was able to withstand all these attacks. Okay, then we move on to then the higher threat levels when the attack is being made by a firearm. Here we can see the different threat levels as per the EN 1063 standards. So this is a European standard which gives 7 different levels of different ammunitions, And the difference between these threat levels is the speed of the bullet and the size of the bullet. So BR1 is the lowest level and the BR7 is the highest level. And generally, we get inquiries for the BR4, BR5, and BR6. These are the most commonly followed threat levels for important buildings. And then no spall is, as I mentioned before, like when someone is sitting next to the glazing, so there is a perceived threat of getting injuries from the glass or maybe from the small splinters of the glass, which might happen because when the bullet is hitting the glass. So the bullet may not actually go through the glazing, but because of the small splinters, people might get injured sitting next to the glazing. So there you need a no spall solution. So we have a solution for that as well, which we will see in the coming slides. But before that, let me just talk about the US standard, which is NIJ standard. So this is also one of the very, very common standard specified for important building specifications, level 1 to level 4. This has got 4 levels. And similar to that, we have the UL standard, which has 8 different levels. As we can see, the level 3 is very similar to what we saw in the previous standard, which EN 1063. This is like, if I have to talk in layman language, this is like AK-47 rifle ammunition, which is very commonly used by in terrorist attacks. Yeah. Okay, so when we talk about security glazing, so what we hear very commonly from the industry is that there are some challenges with the existing solutions for the security glazings, that the materials that are used, they are not so durable, and so they have some issues with the weight of the glazings, because those glazings are so thick that it poses a challenge to the fuel efficiency of the vehicle. And of course, because you have a huge thickness of the glass, then it's a compromise with the optical quality of the glass as well. So scientists of Curare, they actually worked on resolving these issues, and so we came up with advanced interlayers which meet all the requirements of the customers, which have been highlighted to us. So thanks to our advanced interlayers, so we can make the BRGs or the security glazings, which have got a very long life because of the advanced interlayers, and they are lightweight, they improve the fuel efficiency of the vehicles, and also in buildings. So you have to you can fit the same glazing in lighter frames, and there is no compromise with the safety of with the transparency of the glazings. So they have got good optics, and of course they are easy to process for our customers. So here I have an illustration of the comparison between the conventional BRGs or the bullet resistant glazings made with the conventional materials. So they are quite bulky. They have durability issues, and they have got very low scratch resistance. So for that reason, they need to be replaced quite often. Although they have got a anti-scratch coating on that, but it's not good enough for the lifetime of the building. So then the advanced interlayers will help the BRGs. They become 15% lightweight. They are highly durable. They are high scratch resistance, and they have got a very high resistance against chemical attacks also, and they are easier to process. So you might be wondering, like, what's this Spall Shield CPET, which is mentioned over here. So this is a very excellent product from our portfolio, which is used for anti-spall solutions, which I mentioned before. So what it does, I will not say anything. I will just play this a very interesting video, and you will understand very quickly what is Spall Shield. Yeah. So this is a video from one of our customers for a BRG application. So here we are trying to shoot bullets through the glass, and what you see is the striking face of the glass. So that you see the bullet hitting the glass and the splinters of the glass flying. And this is the protected side of the glazing. So the other side is completely safe because there are no splinters. So the other side is absolutely safe. So definitely the glass construction is stopping the bullets. But if we have to make the person sitting next to the glazings, you need to have this PET film, which we call as spall shield or anti-spall. So this actually helps make the glazing absolutely safe. So you saw the third bullet hitting the glass, and there are no splinters on the other side. Yeah. So now you see the third bullet has also hit, but there are no splinters at all. Yeah. Okay. So moving on. So when we talk about lightweight glazings, so here is a comparison of the reduction in weight that can be achieved if advanced interlayers from Curare are used. So I have made this comparison for the NIJ level 3A and level 3. So with the conventional BRGs, as you can see, the glazings are quite thick. And if we talk about in terms of percentage, like, the maximum weight reduction in terms of percentage is 15%. And also, I came across one BRG solution from one of the leading manufacturers of glass. So they have a BRG solution for NIJ level 3, which is almost 67 mm thick. And our solution is 40% lighter than that. So that's a significant reduction of weight of the glazing if it is used in a building or in a car. Okay, moving on. Yeah, so when we talk about BRGs or the bullet resistant glazings being used in automotive applications, then it's very important to make sure that those glazings are absolutely durable against attacks of chemicals, which have been listed in these two tables, because the most of the automotive standards, they feel actually it's not only automotive, but even in case of buildings, often some chemicals are used to clean the glass surface. So it's important to make sure the glazing or the glass is absolutely resilient against attacks from these kind of chemicals. And so we have done a lot of testing for all these chemicals, and you can see the spall shield CPET has absolutely no effect, and its optical quality remains up to the mark even after exposure to these chemicals. It's a clear winner against the other conventional materials like polycarbonate or acrylic. Then moving on to another type of security glazings, when there is a perceived threat of blast happening outside a building. So you need to design the facade against attacks from shock waves which might be produced when there is explosion happening outside the buildings. So on the picture on the right hand side, you see two different test methods. The first one is the shock tube test, where you simulate the blast or the shock wave inside the lab. So it's possible to simulate that. And at the bottom, you see the photograph of a real bomb, which is exploding in front of a building. This building is making use of the glass specimens which need to be tested for their performance against the shock wave. So if you have a very precise idea of the anticipated peak pressure and the impulse, then we can do the simulations for you in WinGuard software. So we will need this basic input from your side, and we can let you know the optimum glass combination that will help you achieve the desired performance. So when we talk about the desired performance, then what is that? So let me just move on to the next slide. So this is a pictorial illustration of the performance levels which tells you that how you want the glazing to behave when there is an explosion happening outside the building. So the level 1 is the most safest level. As you can see, the glazing is not even broken. So the glass is intact even after breakage. In the level 2, glazing is broken, but it is retained in the frame. And level 3, the glass fragments have flown up to a distance of 1 meter from the glazing after breakage. And then level 3B is they can fly up to a distance of 3 meters after the explosion. And level 4 is definitely not the one of the safe levels, because glass fragments can go and hit anywhere. Yeah, so the most commonly used safety levels are actually level 2 and level 3A. Definitely you can design for level 1 also, but your client should be willing to pay for that. So if your client has the money, definitely we can suggest this combination also. But it's good to know that with Sentry Glass you can design the glazing to achieve very high performance levels, like level 2 can also be achieved for a pressure as high as 40 psi. So if I just go back and show you that, I forgot to mention that these are the commonly followed pressure levels for important buildings. 10 psi is generally a very good pressure level that is considered for all the federal buildings in the US, recommended by Department of State for important buildings. But for even more important buildings, maybe like for, I'm just guessing, like if maybe the White House, maybe it might have been designed for a pressure of 40 psi or even higher. So yeah, so in those kind of situations, our products can help you meet the desired performance levels. And the spall shield can also be used to make it even more safer if you want to prevent this risk of injuries from the glass splinters, as we have seen before. And this is my last slide. I'm just I'm going to just summarize the advantages of the security glazings which are made with advanced interlayers from Curare. So they have got the highest optical performance, as we have seen. Sentry Glass, which is the most clear interlayer available in the market. And then we have spall shield, which is also having a optical clarity next to the glass. And then we have after years of exposure to the UV radiations, so these materials have a capability to retain their high optical performance after years of exposure to the UV radiations. And then when we talk about the high resistance against weathering, nature can be very, very cruel to any material. So we have tested our advanced interlayers like Sentry Glass for very high aggressive conditions to the extreme conditions of Florida, where the laminates have been exposed to the harsh and high humidity conditions for more than 20 years, and we haven't come across any defects so far. And most importantly, it's important to highlight the performance of CPET or the spall shield interlayer. So it can withstand very high temperatures up to 16 hours as recommended by ISO standard 12543 part 3 standard. So this is a requirement for a normal laminated glass. So a BRG application made with the conventional materials like polycarbonate or an acrylic sheet, they cannot withstand this test, and that's the reason spall shield has a clear edge over the conventional BRGs. So that's why we strongly recommend this material to be used when you want your glazing to perform at all ranges of temperature. And then as we have seen before, our glazings are thinner and lighter. They can make not only the glazing lighter, but also the framing system, which is required to install the glass. And after breakage, the glass might have to be replaced after some time. So that also becomes quite easy if you have a lighter glazing installed in the framing system. Yeah, this was all from my side. Thank you very much. for listening to me. And I think we are open to questions.
Thank you, Mavinda. Thank you for sharing with us the science and new material that can help the industry to achieve a lighter weight and yet performing security glazing. So I'm glad that there is actually questions coming in, but because of the interest of time, we'll probably do that towards the end. Or we encourage, we still encourage audience to continue to give us the questions. We'll try to answer at the chat box, requesting the speakers to type in the answers if we can. If not, later towards the end, you may key into the feedback form and we'll channel them to the speakers to follow up. So okay. Yeah, thank you.
Thank you.
Digital transformation is actually a journey, not just a destination. I learned that Arup has been embracing digital journey for many years. It started with addressing the complex form and geometry in architecture design, which then progressed to setting ambitious goals to integrate digitalization into their design process and thinking. This brings me to welcome our next speaker, Michael Chin, Principal and Façade Leader with Arup Singapore. I'm looking forward to hear his story and sharing on Arup's digital journey and highlights. So Michael, over to you.
Hi. Let me just share my screen. Are you seeing my screen?
Yes, Michael, we can see your screen.
I see my screen, huh? Okay, so I'll begin. Good afternoon, evening, wherever you are. I'm Michael Chin, and I'm the Principal Facade Engineering Lead for Arup Singapore. All right, so today I'll talk a bit about Arup very quickly. We are a global company, 88 offices around the world in 33 countries. Our revenue is over in excess of 1.7 billion, and we've been operating for 70 years. In fact, this is actually our 70th anniversary, and we've got 15,000 staff and counting. Right, Arup is multidisciplinary, and by that I mean we've got essentially all the core services as well as the specialist services. These are just some of them. In Singapore, we've got about 400 people in the Singapore office. Well, this is a quote by Ove Arup. I'd like to start with that. He always encompassed or espoused the principle of total engineering, right? And even back in the 1970s, when he did his key speech, he's already talking about total engineering, and that's how we want to design, whatever buildings that we are involved in. So essentially, when he said that, when engineers and quantity surveyors discuss aesthetics, architects study cranes, what cranes do, then we're on the right track. So the principle of total engineering is not new, right? And this is what in Arup we like to call the approach. That's our approach to design, right? And we kind of start off with the basic needs, and that's what you imagine a building, that would be the enclosure, the structure, and then as you go higher, the performance, the functionality, and then we talk about the building performance. All right, in today's context, we are talking about U value of glass, SC of glass, and what are the different components and how do they perform. Of course, aesthetic and image. Obviously now, with many buildings trying to achieve more and more ambitious design, and eventually we as engineers we try to get all of them together and hopefully achieve what we call holistic design, right? At the top we call it utopia, but very often how to achieve that is an issue. And in today's context, that's where digitalization or digital tools have become an enabler, especially for us engineers. So this is just one of the workflow that we use. All the different software, the different logos they're looking at, from actually doing the structural analysis to looking at geometry, and then facade optimization, your thermal performance, and then on the right hand side you've got your documentation, right? Revit, AutoCAD, something that we're very familiar with, and of course now we are even talking about visualization and virtual reality and all that, right? So without tools, without software, without digital, that's a bit hard to establish, although the thinking has been there for quite a while. So today I will talk about 3 topics actually that we have been working on at Arab. First one is facade canvas. Second one is actually how we solve complex design issues, mainly our geometry and modulation studies. And of course, the last one is digital inspections. So facade canvas is an in-house tool that we developed, right? And it's essentially our definition of parametric design exploration. Right? We do exploration from time to time, and we what we call optioneering, day in, day out, and in what is the quickest way to do it. We want to do it as efficient as possible, because this process, essentially a circular process that go round and round until you get a solution that you want. And in the olden days, we kind of look at things in 2D, right? And obviously architects has their drawings, their elevations, their GAs. And of course, when it comes to a different consultant, the structural engineers has one set of drawings. The facade engineer, at the time we don't even have facade engineers, he will be looking at his set of drawings in that sense. And all of that becomes a bit hard to really understand, and also capture. Especially when you want to do design, it becomes even more difficult. So now, with software, we are looking at single source of truth, right? We are looking at one model. Daniel talked about BIM and all that, and it's so common now. But essentially, for us facade engineers, we want even more important that we do options, again and again. And now we're even incorporating structural engineering tools into the software and what we call facade canvas. And what comes out at the end of it, to the client and architect is something that is easily understood, something that has already gone through the structural engineering rigors, and essentially you can incorporate things like performance, thermal performance, acoustics, and even in today's context, carbon. All that you need is actually a script. Okay, so we are developing libraries within Arab, to look at how we categorize the different facade systems. And within all of these systems will be quite familiar to you. And essentially, it's very often that, for, let's say, for example, curtain wall, right? One system, we look at different options. So you got one option, you move the spandrel up, in one option. The other ones, you increase the vision panels, you move the sunshades up and down. And when we were doing AutoCAD, that was kind of quite a difficult process. Although we can imagine it, but we don't really know how to convey that. So essentially, using the software, and this is built into a series of Rhino and Grasshopper scripts, we can quite easily get all of these things done very quickly. So any options that you want to change, right, within the parameters of this design, you can, right? And essentially all of these are just with a few clicks, and essentially we get the different options. And similarly, this one here, in the case of refurbishment, we can also do the same thing, easily looking at essentially looking at parametric design in a very quick and easy manner. Right, all of that is done in a software, in a tool that we can eventually add on more and more scripts, at the end of the day, to make our life and design process a lot easier. Okay, let's talk about geometry a little bit. It is also something that we do quite a bit, and you will be quite familiar with this structure, jewel. And we kind of look at it this way, the end product, it's pretty complicated. How do you actually get to that? I would say without any 3D tools and software, and the methodology that we go about getting to whatever it is now, you will never be able to get something built, in that shape or form, right? And essentially, it kind of start with this, and of course, architect has his renders and the competition is won. The architects and its early consultants, design stage, will essentially work out some of these inputs, right? And essentially, it goes around a few parameters. Right, so this is something on plan, this is something on elevation, but essentially there are a few points that the design or the design concept has been given to us. You've got a point at first story, you've got the points at the ring beam, which is on the 5th floor, and then you've got a top, what we call a point on the roof. And at the end of it, you've got the point at the end of the curve, call it the curve. And that's where, after this, the water flow will start to come down. And how do we actually get from here, or the way to actually all of these parameters and build it into a shape, that can be buildable. And it's not, if you look at it, it's a series of arc curve, with a certain radius, and it comes to a certain point, it's actually spline curve. And when you say spline, means it's essentially connecting the points, two or 3 points together, the best curve that you can, doesn't confine to a specific radius, right? And using, again, scripting Rhino and Grasshopper, and we had to look at what is the existing geometry. There's a model that was provided, and essentially we're going to look at the gradient at every point. And when you look at it, when you smoothen it, and basically what we will come up with is, when we actually build it, to get to a structure, you need to have all the different elements. You can imagine all of these are segmented glass, and eventually what will happen is, every one of that piece needs to be quite smooth, and that's the reason why you can't conform to a specific geometry in that sense, right? It all depends on requirements or building requirements to actually form the shape that you want. So eventually, going through this process, you essentially build the curve, that curve, the curvature on that model, what we call surface regeneration, through this process, so that you can get almost a smooth kind of surface around the entire structure, right? And then once that is done, essentially you call that modulation, or the geometry is done, then you start looking at different options. All of this may look alike, but they are slightly different, right? And that's where you essentially look at things, what we call horizontals, and the number of panels, and that actually led to the maximum glass size. Every one of them has slightly different modulation in that sense, which is leading to different sizes and different quantities for different things, right? So without software, without digital, no way, we can actually get all of these things out. Of course, you can do it by hand, but that will be painstaking, right? So this is another one that we do. I think it's quite familiar to some of you, right? It is a drone view, and essentially, when you look at it, it's 4 towers, and they're all connected by this so-called sun shading element that goes around. And the design intent was just a series of curves like that, and it's different on every level. And frankly, it's a series of spline curves, and it doesn't make quite a lot of sense in that sense if you start looking at it, because every piece, if you look at the one on the left, every piece of that is one different color, right? And one different color is one different size. Every floor is 2,300 panels, thereabouts. And you can imagine, if you're going to build that, a contractor is going to build that, it's going to run into big problems, and of course, big costs. Every piece is different. So you run through it with a series of scripting. Again, it goes to the left. The right option. You kind of relax, what we call a dynamic relaxation, and you put it within certain boundaries, using a script. And essentially, you can then kind of smoothen the curve a little bit, and bring down your panels, to smaller and to more regular repetitions. Frankly, you can't tell at the end of the day. Yeah. So there are things like that, ETTV calculations, which are very familiar to you. BMU, BMU is always an issue. I won't talk about that today, but that's we've always done BMU in 2D, right? Maintenance, and that's always an issue, right? People can't imagine, where would this gondola and how is it going to be this area, how is it going to be maintained, by the BMU, and all of that done in 3D actually makes it a lot easier. Yeah, ETTV is the same thing. Agree. It's no longer a regular shaped building, where we can just use a spreadsheet and do our ETTV. Nowadays, all the buildings are curved, facing different direction, and by using a script, you can easily get the ETTV out quite quickly. Right, which goes to my last bit on digital inspection, right? And the thing is, what are facade inspections and how typically how we have done it in the past, right? And you imagine, how can you actually do that? Previously, you go down with a gondola, a guy, the inspector, has his 2D drawing, 2D markup drawings, and then you go down every floor, you inspect, and then you try to mark it up on the elevation if there are issues, and you're kind of depending on one inspector doing it all right? And he's the eyes and the ears, and he basically tried to do quite a few things at the same time. And of course, he's up there hanging out in the air. And then at the end of the day, you can imagine all of this data, being compiled in piles and piles. It's not easy. It's very time consuming. One building full inspection, the last time around medium size, probably take us 6 to 9 months to actually do a full inspections, right? That is definitely too much time, and not very efficient and not very accurate, right? So then we'll start to kind of look at it and see how can we kind of streamline this workflow, right? We call it digital workflow. And we started looking at that model preparation. Is there something we can do on that front? And then after that, we start looking at every stage of our inspection process to actually make it smarter and make it more efficient, right? So it runs across model preparation, coding and programming, and of course inspection, the physical inspections. We've obviously got human still hanging there outside in a gondola, but we also start using drones and all these tools to actually help us. And of course, the final one is report writing, and that's the part where don't underestimate your piles and piles of data. How to make sure that you're accurate and those numbers are accurately captured. Right. So I'll start with the model preparation, and of course, you've got a building, you've got an as-built drawings. It's easy, and we kind of built a Revit kind of model, similar to a Revit model, and we built it from scratch, and we essentially built a model pretty quickly using the as-built drawings. But sometimes your existing buildings they don't have as-built, right? Because they're quite old, and that's where some of the problem lies. And we actually got to use tools like the metaboard scanner, and also some of the drone scanning devices that we have to actually build the surfaces from ground zero. And so essentially build a model just based on the sort of scanners that we have in the market. And using that, we then this is kind of like the existing Matterport scanner, the LiDAR scanner on the internal front, right? And for clear spaces like that, you can actually get quite good model, and it's quite accurate. then after that, we start, that's the difficult part. Essentially, when we build a model, it's kind of like a surface model. When we have a Revit model, we actually need to link each and every one of the images or the drone images to the element or to that model. So we know exactly where the elements, where the defective elements are. And the whole kind of process is built around this. You've got 10, for example, your whole drone come up and down, or your human going up and down, right? You collected 10,000 photographs, for example, and how to link them, where previously you were do, mark it up on your 2D elevations. Now you actually immediately mark it on your model itself, using either the drone images or the human essentially holding for example, an iPad or Android device, which is linked to that model. So it's a lot more accurate, and the data is stored immediately. There's no no difficulty, no inefficiencies to retrieve sort of like the files later. Yeah, and also that last part that I was talking about was the report writing. Again, all of this can then be generated into reports quite easily. And a lot of these reports essentially, because they're inspection reports, so there's quite a lot of repeats, and the format, as you can see on the right, for example, when you're doing inspections, all the inspections are done, identified at the point of inspections, and then it goes straight into a report in a report format, right? So there's very little things that we need to add on, except maybe the executive summary at the front and of course the summary at the back. The best thing about it is we can get data out of it. We know how many defects that we can that the building has, and then we can do charts like that, which essentially means that it's a lot more interactive. A person looking at it would know, oh, from this elevation, it seems like the southeast elevation, the northeast elevation seems to have a lot more defects compared to the other three elevations, and then this data can be communicated more effectively in that sense. I think that's my last slide, and essentially this is the first project in Arab, right? And of Arab's first project is actually the penguin pool in the London Zoo, and essentially it was kind of the first project that was built quite closely together with the architects and the contractors, using expressive and structural precast concrete. And during those times, it's really quite special to have a structure just based on concrete like that. It's thin and very expressive. And that process, he's attributed it to the whole process of total design. That he's thinking back in the 1970s and even earlier. Even at that time, always think of design as total design, right? Rather than every single different disciplines working together, to produce a product. So I think my last point is we have all the visual tools that we have, but they are all enabler, right? The main thing is don't lose sight of the design itself. It's all to help us deliver a better design at the end of the day. Okay, I think that's the end of my presentation. Thank you very much.
Thank you, Michael. I like the last slide. It seems the penguins are having fun with that design.
Unfortunately, they're no longer used.
Oh, okay. But yeah, okay. So I think we have now come to the Q&A panel session. So can I call upon all speakers to come on the screen? And we have received quite good questions. Unfortunately, due to the time limitation, I'll just ask one question for each speakers. I'd love to lead this conversation. Maybe to start off, can we have Michael, since you are the last speaker, would you be able to share how can digitalization in construction and facades help in decarbonization of the construction industry?
Yeah, I think when we say decarbonization, everybody is kind of like talking about it in the next big thing, right? And everybody now, we just finished our COP26, and decarbonization obviously it's a big item, and we actually don't know where to start. All right, and because it's such a big issue in that sense, but for us, I think everybody have to take their small little steps in that sense, and from a design point of view, we definitely have a big role to play in terms of when we are designing certain things, make sure we do a lot more now, like say what I mentioned earlier, modular, right? Modular construction, and we try to make things that are a bit more long-lasting, more durable. So you design things that are more, instead of just looking at aesthetic, where previously we really focus on, now even the architects now has already, moved towards something that is, okay, I mean a bit more holistic. If you look at maintenance, if you look at replacement, if you look at how we actually going to recycle this element at the end of the day. So plug and play, we can put it back, we can install it today, but at the end of it, we may be able to take it out and then reuse and recycle. So I think from that front, as designers, as engineers, that's where we can add value in that sense.
Michael, thanks for sharing your thoughts. I do agree we have to move beyond. Of course, aesthetic is still important, but to have that holistic view. So having to say that, maybe I'll move to Daniel. Could you also, we have heard from you about the digital workflow. Would you be able to share with us what is the biggest challenge in the digital transformation for Ong & Ong Group?
Yeah, hi. Thanks, Glenn, for the questions. Okay, so in our context is apart from implementing those tools, I mean tools perhaps is the easiest part. The biggest challenge will be to change the mindsets of the people, to change the mindset of our staff and the whole entire, I guess, from the management all the way to the staff level as well. Right. I think I guess for us, it's lucky that we have a good support from the top. As well as the from the bottom up also the staff is keen to learn new things. So I think the key thing here is like, yes, mindset is the main kind of a challenging part. So if the staff want to do the old ways and don't want to change with the new ways of thinking, new ways of doing things in design, then that will be, I think that's the one that can, I guess, pull you back from the progress. Yeah.
Thank you, Daniel. Definitely change of the mindset is very important, and having the buy-in of the whole team as well as the industry. So let's move on a little bit to talk about the material side of the things. So Salva, you have shared with us about optical distortion. So we do have a question that asked, optical distortion sometimes comes from glass processing. So in your point of view, are the optical distortion from glass processing bigger, smaller, and how do we add that up when it comes to glass bending in a facade?
Okay, so the distortion certainly can come from the processing in terms of roller wave, in terms of edge kink, in terms of overall glass bending. Of course, they add up poorly. We cannot really predict them, but we can regulate them. Usually the standards of any country, so Russian, European, American, they are quite lenient on the glass processor in this case. So 3 mm per meter is allowable, no questions asked. It adds up to the glass bending because of the climatic loads. But the best thing to prevent this is to, again, predict. So when you're doing something when you're planning to build a building, make a list, state your demands, state your requirements clearly, and then control them. That is the best thing you can do. So They can be estimated, yes, but that's not a question of digitalization or math. It's just, you know what can happen, so you regulate it in advance. Best way to do, best way to go.
Thank you, Selva.
Thanks, Gwen.
Thank you so much. Thank you. We also have a question for Malvinder from the audience. That is, with regard to safety, if we have a tempered glass and put a safety film on it, how is the performance as compared to laminated glass?
Okay, so when we talk about safety films being applied on a tempered glass, I believe those are applied on site. So these are applied like when the glass is being installed or post the installation of the glass. So then durability of those films will always be a question mark, because if we look at the lamination process, that is done through nip rolling and followed by the autoclave process. But these films which we are talking about, these films are applied at the site, not under the influence of heat and pressure. So they have a tendency to come off the glass surface after some years. And I have personally seen such films being used on glass railing applications as a retrofit measure. But as I mentioned before, these films have got a lot of durability issues, and one can easily scratch those films from the glass surface very easily. And when we talk about security applications, because these films are safety films and they don't have got the hard coat scratch resistance anti-scratch coating on their surface. So for that reason, there is no fair comparison between the two, I would say.
May I add up, if I may?
Yes.
Because I've been working 6 years as a chief technologist. Even if the film, if applied on the factory side, I mean, not on the building, there are two things. First, as Malvinder said, it scratches far easily, but the most important thing, that the thermal expansion coefficient of glass and of the film is very, very different. And so the film will with certainty go off eventually. Yeah. And that is the main thing for the lamination. Sorry for adding up, but from my experience, film is a substitute.
Thank you very much, Slava. I wasn't aware about these films because I know my PVV and my Sentry Glass. I wasn't really aware of these films. Thank you for this point. Yeah, thank you.
Yeah, that's great. That's the purpose of such platform, where we can share, knowledge within different people. Sorry. So since we are on the topic of digitalization, I was thinking maybe I'll just share a question just to tap on the expertise. So for the expertise here, what do you believe is the most promising digital design process or even material breakthrough that will have the greatest influence on the future of our facade in the next 3 to 5 years, whether it is a contribution to productivity or sustainability aspect? So anyone wants to give a go first?
No, I would say, okay, maybe I would say the simplest thing, but the complex design. And the complexity of design is constantly rising. So for my opinion, the complex design, which is we will look into the future more and more, will include thermal performance, energy performance, comfort, estimation, and with all of these shading devices, which were seen in the first presentation. That is a good thing. This complex design can give you a lot and lets you plan a lot in advance, combined with calculation tools, and way to go. That's my opinion again.
Thank you, Selva. Yeah, I think designs are getting more complex, and that's definitely digital tools like calculation, advanced calculation will help us to achieve that, as you mentioned. So
I have a goal with that. I think, yeah, on one hand, we are seeing a lot more ambitious design, right? Complex design. that's you can realize it using technology and tools, and but on the other hand, you look at it when we start looking or putting the carbon story into all of this, the whole equation may just change, right? If you look at aluminum and glass, right? These are the two materials that are familiar to me, because steel and all that. These are all very intensive, carbon intensive industry. And frankly, they use a lot of energy to to actually make the raw product, right? And in fact, 70 to 80% is your scope 1 and scope 2 carbon, and essentially we've got to find ways, if we want to get to that 1.5 to 2 degree reduction, right? We've got to find ways to cut some of this out, and I don't be surprised eventually we will use systems technology to actually help us not to go there, not to go so complex, back to basics, a bit more simple, to me, I think that could be a story, possible in probably the next 2 or 3 years.
I think to add up to Michael, the biggest advantage of the digital tools is that they not only give you how much carbon you are saving, that is all good, but for customer, usually much more convincing thing is money.
Yeah, of course.
So for him, digital tools can help you evaluate the savings and convince the customer to make the building better. So it all go hand to hand in this case. So digital tools are very useful for this particular thing.
Agree. I think, in today's context, obviously, a lot of things talks about cost, ROI, and but imagine if your carbon tax is 5 times of what it is now, then we will be looking at different ROI now, different story.
Correct.
Michael, I'm not denying the carbon thing. No, I'm just saying that they are going together.
Yes, so I think it will be interesting if there's a tool that can help to calculate, like what Michael said, the scope 1 and scope 2 in terms of the embodied carbon that comes with it. And because of the use of maybe higher performance glass, as Pilkington is offering, or even special laminates, such that it can generate energy efficient from the operational carbon. And whether at the end will it be able to offset, I'm not sure. But I think it would be great if there's such a tool that can help to calculate, to help the industry to make the best decision. So Daniel and Malvinda, do you want to share your insights? Or what you think will be the promising things for the next 3 to 5 years?
Yes. So I mean, the whole thing about digital is about data, right? I mean, we talk about BIM, it's a building information modeling. I think the key thing here is more on the information, right? It's rather than the model itself, because the more data that you put into the system and the platforms and in the project, right? I mean, is a lot, is huge. Like, I mean, we're talking about, like, perhaps if you have a collections of all the projects that you have over the past 5 years or even few years, for the past 2 years even, right? I mean, all these data actually can help for your future design. So then the thing with the technology, with the data minings, machine learnings and AI, I think that's the one that can help us to actually to make sure that our design is more green, is more kind of, I guess, carbon friendly, right? At the end of the day, BIM and the whole VDC and IDD is about to achieve low carbon economy anyway. So it's like, we are in that process. I guess it's a long journey, but I think we have a good base now with the effort of the industry to push into building information modeling, getting into the FMA, like, design for manufacturers and assembly, because all of this is actually to, apart from make us more productive, but also less wastage in terms of the the productions and all that, right? Because because you model it first, you do it virtually first before you actually produce it in a factory, right? So then you can actually estimate, right, how much wastage you can actually save and so on, and make sure there's no mistakes, right? Because in the past, without technology, you just do it and then suddenly you have to knock the walls again on site and then build it again, right? I mean, that is kind of too late already. But now with digital tools, you actually can simulate everything with in a virtual environment before we actually build it. I think this one, the whole thing is actually can really helps achieving the low carbon thing. Yeah, especially now with the automations, with all the robot helping us, right? All this kind of stuff with the AI and things. Yeah.
Yeah,
I think we are in the right
data
direction. Yeah.
Sorry, Mavinda, were you saying something?
Yeah, so I have also similar thoughts, and we as the manufacturers of the interlayers for laminated glass, so I think the biggest challenge for us in the coming years would be to make our products, which are C2C, which is like cradle to cradle certification. They have the C2C certification, and they have got very low embodied carbon content. So when we talk about the laminated glass as a complete application, so currently it's not like commercially very much viable to recycle the entire glass, laminated glass, because delaminating the glass of the interlayer from the glass, that's a very, very big challenge. And it's some companies have actually ventured into this area, but it's not on a very, very commercial level. But I think as the governments of various countries, they are striving to reduce the carbon footprint of the buildings. So I think this will become more and more important for us to come up with more innovative solutions where, not only the interlayer, but the glass as a complete unit can be recycled, Yeah.
Thank you. I think the takeaway for us is definitely, digitalization, big data, machine learning is going to help us to have new collaborations, new innovations, and to address some of the challenges we have in our industry, like, how to decarbonize, achieve sustainability, and yet, aesthetically still a very nice design buildings. So I think we have now come to an end of the webinar. For me, it has been very enriching 2 hours. Thank you everyone for your participation. And on behalf of Glasstech Asia and PERAFI, we'd like to say a big thank you to Kurare and Pilkington for your kind sponsorship, and also to our distinguished speakers for your insightful and informative presentations. So do remember, I just want to do one last shout out to remember the date 26 to 28 October 2022 for Glasstech Asia and Fenestration Asia exhibition. So again, the exhibition will be held in Singapore at the Marina Bay Sands Expo and Convention Center. So you may check out the website for Glasstech Asia, or simply following them on their social media like LinkedIn, Facebook for updates. So after leaving this webinar, you'll be directed to complete a feedback form. So kindly complete the form to help the organizer improve for their next webinar. So it has been a pleasure for me to be your moderator and host. Till we next meet, take care, stay safe, and goodbye.
Thank you, Gwen.
Thank you, everyone. Thank you.
Bye-bye.
Bye.
Bye.
Bye-bye. Thanks, everyone.
Bye-bye.